Hello students, I'm Mitosh. So today we are going to discuss different types of questions on Ben's rule, right? So you see, the questions on Ben's rule is one of the toughest questions that you can face in chemical bonding. So here we will discuss three types of questions that you can see in Ben's rule, so that whatever difficult type of questions that you may get related to Ben's rule, especially in the advanced or JEE mains, you will be able to solve them from the knowledge that you will be getting in next 4 to 5 minutes. Okay, so I hope everyone knows what is Ben's rule. I will write it again. What is Ben's rule? More electronegative side atom bonds with less percentages orbital. So I wrote it in short form, right? You assume that you already know Ben's rule. This is just question practice, different types of questions. So this is Ben's rule. Why? Because more electronegative atom will take the easier orbital or more comfortable orbitals to bond, so which will have less percentages, because that will have less electronegativity. Anyway, we are not going into the explanation of what is Ben's rule. So let's see some questions. So one of the very common question that you can get is, or you might have seen it in the previous year question paper, is structure of PF3Cl2. PF3Cl2. Now you know PF3Cl2, fluorine and chlorine both are monad, so they make one bond, monovalent atoms. So by that sense, you can understand what is the hybridization. PF3Cl2 hybridization is sp3d, which meaning geometry is trigonal bipyramid. Okay, so it will look like there is phosphorus, there are 5 orbitals, these 3 will be on the plane, right, and these 2 perpendicular to it. This angle will be 120 degree, right, this will be 90 degree, right. So most of the students end up with an answer. They think, okay, 3 fluorine, 2 chlorine. So the first answer that will come to your mind will be this one, right? All 3 fluorines on the plane and 2 chlorines perpendicular to it. But this is the wrong answer. This will be the answer you end up getting when you only know VSEPR, very basics of VSEPR. But if you know Ben's rule, you should know that this is a wrong answer. So let's see how to get the correct answer. Okay, so I hope you all have written this down. So let's see. So now that I've told you this is a wrong answer, so what is the correct answer? Okay, so to know that, you need to understand this sp3d is actually formed by sp2 plus pd, right? sp2 plus pd. This sp2 is s, well, there is only one s. P is, let's say, x and y, px and py. 2p orbitals are px and py. The rest of the pz, then, and dz square, correct? So you see this, pz and dz square both are on the z axis. So these two orbitals are actually predominantly formed by pz and dz square. And sp2, you look at it, what is the geometry of sp2? Trigonal planar, right? So that's it. So this is predominantly, I'm not saying just sp2 and pz and dz square, that will not make any sense. And when you go to pf5 or pcl5, in that case you will see that it is actually the mix of all this, right? It is 5 sp3d. But what I'm saying is pz and dz square, because they are on the z axis, the z axis orbitals will be predominantly pz and dz square. Okay, so in that sense, let's see, in that sense, I have P here, correct? So in that sense, which orbitals are more percentages character and which are less? So since these two are predominantly pz and dz square, less percentages. This is also less percentages. Percentages character will be more on these three, correct? So fluorine, where will it make the bond? So fluorines, always the preference will be to make bond here first. Now one more fluorine is a well, when the next option is here, right? So the rest of the two that is left will be bonded by fluorine. So this is the structure of PF3Cl2. Now you know what is the reason, because these two are predominantly pz and dz square, so their percentage character is less, so fluorine will occupy them. Okay. So this is one of the PYQ question that you can find on Bend's rule. We have went through it. Now let's go to another type of question. So this is about the structure. Now let's go little more into the details of structure. Okay. Another question, another type of question. I'm not discussing every question that you can find on PYQ. I'm discussing different types, so that any question that you may encounter, you will get some kind of insight from this video. Okay. Now the next question is, let's see. Okay, so we have CHF3 and CH2F2. Okay, I'm not writing the whole question, I'm explaining that question. What are the points? So we have CHF3 and CH2F2. So we have fluoroform and CH2F2. Now let's see what will be the comparison between angle CF, not CFF, FCF on both. Okay, so we have two compounds, CHF3 and CH2F2. Obviously both of them will have FCF bond, right? So we need to compare what will be the comparison, right? So what is the hybridization? You see, you have CHF3 and CH2F2, right? Both are sp3, correct? Both are sp3, which meaning geometry is tetrahedral, correct? So C. Okay, it's a 3D geometry, but I'm trying to represent it in 2D, so you know. So we can get H here, 3F, right? H here, CF, H. Now if I mark, let's suppose this is theta 1, this is theta 2. So the comparison is between theta 1 and theta 2, right? Theta 1 and theta 2. Most of the people would think, see, hydrogen is a small atom, fluorine is a very, compared to hydrogen, fluorine is bigger. So they would think that there will be more repulsion, and they would think theta 1 is actually less than theta 2. Correct? But that is wrong answer. This will be the answer that you make, that you will get if you only know VSEPR, right? But with the insight of Bend's rule, this is the answer that you will get if you only know VSEPR and hybridization. But with the insight of Bend's rule, this is not the case, and I'll explain why. So what is the answer, right? So the answer is actually opposite of it. Answer is theta 1 greater than theta 2. Okay. Now we will see why is that. Okay. Oh wait. Here, yeah, you would assume that. Oh, here you would assume that F. Here you have 3F. So theta 1. Okay. So you'd assume that the theta 2 is actually greater than theta 1 because less repulsion, it can be more, but that's not the case. Theta 1 is greater than theta 2. Okay, so theta 1 is greater than theta 2. Okay, I'll explain why. So look at here, you have carbon, right? So which is more electronegative, hydrogen or fluorine? Fluorine is the most electronegative element. So fluorine will take, so here you see, since all the percentages character will go there, that hydrogen's orbital will be bulkier and the fluorine's orbitals will be like this. Correct? Right? Now if you come to this one, this will be bulky, this will also be bulky, but these two are slender. So you see, you have one bulky group, three slender groups. Here you have two bulky, not groups exactly, sorry, orbitals, two bulky orbitals and two slender orbitals. So where do you have more where do you have more steric repulsion? You have it here. So that's why this angle, right, this angle, because this H, that's why this angle theta 2, and here you have hydrogen, fluorine, and this is theta 1. That's why theta 1 is greater than theta 2, because these we have three slender orbitals and one bulky orbital. Here you have two bulky orbitals and two slender orbitals. So here there will be more repulsion and here it will be less repulsion. Okay, good. Now let's see. So I hope this question is clear to you. You can get a similar question with chloroform and CH2Cl2 as well. Same concept, because both fluorine and chlorine are more electronegative than hydrogen. Now let's look into another question, another type of question. Okay, now another type of question that you can find on Ben's rule is about the, let's say, it's bond length. Okay, so bond length, let's see this question. You have N2F4 and N2H2. Okay, N2F4 and let's say, sorry, N2H4. Okay, N2. Question is comparison of N bond length. See, usually this type of question, the comparison is for either NF bond or NH bond, but here the question is of N bond in different compounds, right? So you have this and obviously there is a lone pair, but that's not our worry. Why? Because that's same in both cases. Now let's see what will happen here, right? So, well, there's a lone pair, so it's not exactly on the plane. These fluorine atoms are not on the plane, because you know the structure is tetrahedral. Structure is pyramidal, but the geometry is tetrahedral. Okay, anyway, our objective is these two. Let's say this is A and this is B. We need to find which will it be greater, A greater than B, or B greater than A, or A equal to B, right? We have, let's say, four options: A equal to B, A greater than B, B greater than A, right? Or none of the above. Okay, so we need to find what is answer. A lot of the students thinking it's just the bond between nitrogen and nitrogen, right? So it should be same, and they go for A equal to B, but that is not the answer. That is wrong. So let's see what is the correct answer. Okay, so here you have A and B. Okay, you have A and B. Now what you can do is, so you need to see, so this orbital is of the hybridized, this is also hybridized, this is also hybridized, this is also hybridized, this is also hybridized. So what will happen is fluorines will go for orbitals with less percentage S character, which will increase percentage S character here. Okay, so here more percentage S character. Here, because this is hydrogen, it can it doesn't it will not force the nitrogen to bring less percentage S character to these orbitals. Because of that, here less percentage S character. Now you see, more percentage S character, more bulkier and shorter the bond orbital. So both are shorter, so which meaning this bond will be smaller. So here B will be greater than A. Okay, so we have discussed 3 different types of questions that you can get in bench rule. One is about the structure, overall structure. Next is about the bond angle, and another one is about the bond length. Now you revise these questions and practice similar questions in your question banks and everything, then bench rule will be very easy for you. Thank you.